Good morning and welcome to Purdue University and the Computer Security Seminar. Our speaker this morning is Mohamed Shehab from Electrical and Computer Engineering here at Purdue. He's a PhD student, and his topic today is watermarking relational databases.
Hello, good morning. So I'm going to talk about watermarking is well known in a lot of areas where there is audio, video, and other types of media. Today I'm going to talk about a special type of media, which is relational databases. So the outline of my talk, I'm going to start with some introductory material, telling you about what is watermarking and why watermarking and how watermarking can be done. And then I will talk about the general watermarking model. Then we will discuss one of the watermarking techniques. Actually, it's the first watermarking technique introduced by Rakesh Agrawal. And then we'll talk about another one introduced by someone in Purdue, Radu Sion and his group, Mike Atalla, and sorry to miss the last one. And then the future challenges and the references used in this talk. Okay. So what is watermarking? So a watermark is a signal. In our case, it's a stream of bits. It's a signal that is securely and imperceptibly and robustly embedded into the original content, producing a watermarked signal. So why did I highlight robustly here? Because there are two types of watermarks. There is a watermark which is robust, and there is a watermark which is fragile. And according to the application, we would like to design a robust watermark or a fragile watermark. So what does the watermark describe? It describes information that can be used for proof of ownership or tamper-proofing. So tamper-proofing is like integrity checks on the data, while proof of ownership is that if you design a document, you want to prove one day that you are the owner of this document. So watermarking can be divided into two types, a robust watermark and a fragile watermark. So a robust watermark is a watermark used for proof of ownership and copyright protection. So by robust, I mean that the watermark, the attacker will have a very hard time trying to remove the watermark from the data because the watermark is robust. And what makes it robust is the technique that we will be using to embed the watermark. The other type of watermark is fragile watermark. A fragile watermark is a watermark which certain changes to the data will disturb the watermark. So this disturbance of the watermark will tell you, hey, this data has been altered. Okay, so that's why it's fragile. So in fragile, we will be using it for tamper-proofing and data integrity. So in this talk, I will focus on the robust side of watermarking. Not a lot of research has been done in the fragile part, even in media, because it's very hard to design a watermark which you can retrieve and changes. So there is two contradicting assumptions here, that the watermark will change and you can retrieve it. So that's what makes fragile very hard. But robust is you are trying to hide the watermark in very secret places where even the attacker cannot reach to these places. Okay? So why watermarking? So watermarking is done because digital media can be easily distributed now, copied through the web. And database outsourcing is a very common practice. Database outsourcing, what type of data? For example, stock market data is being outsourced, consumer behavior data. We have a big database here at Purdue by Walmart. And the power consumption data also at Purdue, we have power consumption data. And the weather data. So all of this is being outsourced continually. So Watermark provides a very effective way of proving ownership. Why? Because if you embed a watermark in the signal, this means the signature information is inside the signal itself. I mean, it's inside the document. So you don't have a document and a signature. No, the signature is embedded in the document. So they are all acting as one object. So signature and data are the same object. And it also devises an effective means for tamper-proofing. The integrity information is also embedded in the watermark, in the data. So why is watermarking possible? And if I'm going to embed something in the data, this means I will have to change the data, right? So if I will have to change the data, this means this data should tolerate the change that I'm going to make. So real-world data sets can tolerate a small amount of errors without degrading their usability. The magic word is usability here. Okay, so usability, I have the next slide will talk about usability, but let's see, for example, some examples. The meteorological data in building weather prediction models, the wind vector and temperature accuracies in this data can be estimated within 1.8 meters per second and 0.5 degrees Celsius. So this is the amount of error that happened when you measure this data. So this amount of error gives you a usability region, which you can play with and alter the data in that region. So you can play with, for example, the wind speed with a percentage of 1.8 plus or minus. Okay, and then so these constraints will bound the amount of change that you can do on the data. Simple. Of course, I will not be changing the data haphazardly. No, I will have constraints that I have to abide by. So what defines the usability constraints? So the usability constraints are application dependent, obviously. So why are they application dependent? For example, alterations performed by watermark embedding should be unidentifiable by the human visual system, for example, in images and video. So if I have an image and I embed a watermark in the image, the images before and after watermarking will have to look the same for to the human eye. Okay, that's application dependent. For example, consumer behavior data, watermarking should preserve periodicity properties in the data. So consumer behavior meaning that every day you go buy, for example, milk from Walmart. Okay, so there is a periodicity. Every day people buy milk from Walmart. If I'm gonna embed a watermark in this data should still give me the same periodicity that every day people buy milk from Walmart. Okay, at certain periods of time, whatever. Actually, I was surfing the web today, and I thought maybe I should bring this just as a small example. So, for example, Google has provided a new service called maps.google.com. Maybe you can try it out. And if you look closely here, you'll find that Google embedded watermarks. But these are visible watermarks. You can see them, right? Why did they embed the watermarks? They want to prove ownership on this data. Did this watermark affect the usability? Yes. But did it affect it large enough? No. I can still, this is of Chicago, actually. I can still define the main regions of the picture while the watermark is still there. So usability is application dependent. Okay, what are the properties of the watermark that I would like to have, or that we would like to have in our design? Detectability. And this detectability meaning that the detectability is based on a secret key. So I can easily detect, the watermark can be easily detected only with the knowledge of the secret key. Okay? Robustness. The watermark cannot be easily destroyed by modifying the watermark data. Imperceptibility, meaning that looking at the data, you cannot find the watermark. Yani the watermark is imperceptible. Presence of the watermark is unnoticeable. And a blind system. A blind system means that to detect the watermark, you don't need the knowledge of the original data. You only need the watermark data and the key, of course. So you do not, because if you see, if I have the knowledge of the original data, the problem becomes very easy. All what I do is just subtract both of them, and then what is remaining is the watermark, plus the attack produced by, plus the effects of the attack, plus the effects of the attacker, right? So that's why we emphasize the blind system. Makes the design a little bit harder. Okay, so what did we talk about until now? We introduced watermarking, and we motivated the problem a little bit. The next section, we will talk about the general model of watermarking. So here is the general model. We have our data. You can see the pointer, right? Okay. We have our data, and we have 3 blocks. The first block is the watermark encoder. And providing a secret key, the data, and the watermark is generated. The watermarked version of the data is generated. And then it is being exported to the, so who performs this? It's the owner of the data. He watermarks his data. Then he ships the data to a client. So when it's being shipped to the client, an attacker can attack this data. We will discuss what types of attacks that he can perform on this data. And then the attacked version is with the client, or the attacked version is being sold to someone else. Hey, this is my image, but it's not yours, and you are selling it. So how to prove ownership? All what we require is the secret key and the watermarked version of the data. And using